So what is homogeneous function? So when you have a function of two variables, fx, y, we're gonna call it homogeneous of degree n. If for any t greater than 0, f tx ty, this is equal to t to the n fxy. Well, this is the definition of homogeneous function. Well, for example, so let's take a look at example together. Well, first example, let's say if you have fxy equal to, let's say, x squared plus y squared. If you want to know this function is homogeneous or not, so you can check by you compute. So let's consider f tx ty. So basically you replace tx and ty in the function. And then here you're gonna get, well, you replace x by tx, you replace y by ty. Does it make sense? And then you simplify a little bit. So you get t square x square plus t square y square. And then you're gonna get t square x square plus y square. And this is t squared times fxy, right? So you can see that if you manipulate ftxty here, at the end, you get t squared fxy. This match with the definition. You look at the definition in the crowd here. So you can see that the definition say if you simplify ftxty, if you get back t to the n times fxy, this function is called homogeneous. So to conclude, this function f is homogeneous. Well, of degree 2. It is homogeneous degree 2. How do I know that this is degree 2? Because the function that I get, this is t squared. Does it make sense? Well, let's do another one. Number 2, let's suppose I have function gxy. This is the function, let's say x cube and then cosine x over y, for example. Then when you simplify it, so you're gonna get, well, this thing you have g tx ty here, and then you replace by tx cube and then cosine tx over ty here. You simplify it, so you're gonna get t cube x cube cosine x over y. You can see that it's come back to t cube and then gxy, right? Because this is just gxy. Well, the conclusion for this question is G is homogeneous. Well, G is homogeneous as well of degree 3. Does it make sense? You know this is degree 3 because the function that you get at the end, you're gonna get, the function that you get at the end, you get t cube gxy. Well, this is how to check homogeneous differential equation. No, sorry. This is how to check homogeneous function. Well, the reason I have to mention this thing because, when we look at the differential equation on the next slide, if we know that the function is homogeneous, we're gonna have a particular way to solve it. Sounds good? Any questions so far? All right, so we're gonna move to the next one. Let's talk about differential equation. So, well, if you have differential equation in this form, mxy dx plus nxy dy equal to 0. This is a differential equation in the standard form. This differential equation is called homogeneous if the function m and function n, they are both homogeneous of the same degree. Well, we're gonna call this thing homogeneous differential equation. And then you're gonna have, a standard way to solve this homogeneous equation. Does it make sense? For example, if I have, let's say, for example, let's say I have the differential equation. Let's say I have dy by dx equal to y square minus x square over xy. Well, you can see that this is the differential equation, right? Because this is an equation including x, y, and its derivative. Well, you can see that, hey, suppose that you think that you want to check if this differential equation is separable equation or not. First, because you know separable equation is the easiest one. Well, when you get differential equation, you should check first if this equation is separable. You can see that, hey, on the right hand side you have y square over xy and then minus x square over xy here. You can see that this is let's say y over x, right, minus x over y. You can see this is not separable, right? So you cannot use the technique that you learn from the Monday class, because, well, you don't have something on the right hand side that you have a product of function of x and function of y. So this equation is not separable. So you cannot use a technique, separable equation. However, if you simplify this thing, you simplify a little bit. So look at my simplification here. So I'm going to move x, y to the left hand side, right? So I multiply x, y to the equation, and then I multiply the x to the equation. So this is what I get, right? Because I multiply the x on both sides, dx here. So this is going to cancel out, and then on the right hand side I get that. I multiply x, y on both sides, so x, y going to cancel out, and then you can have x, y dy here on the left hand side. Well, I simplify to that thing, and then I simplify a little bit more, so we get x square minus y square dx plus xy dy equals to 0. Well, this match now, it is in the standard form that you have before, that I highlight in yellow here. So you can see that what you have here, this is mxy equal to x square minus y square, and then nxy, this is equal to x times y. Well, if you check this is homogeneous of degree 2. This is because mtx ty, this is equal to t square mxy. M is homogeneous degree 2. The same thing with n. If you do this, you're gonna have n is also homogeneous of degree 2, right? This is because, well, when you compute ntx ty, you're gonna get t squared times nxy, which is the definition of homogeneous of degree 2. Well, because m and n, they are both homogeneous of degree 2, so your conclusion is this differential equation is homogeneous. All right. Well, if you know that the differential equation is homogeneous, you can use the technique of substitution to solve it. Well, we're going to talk in the next slide, but well, this is how to check. Well, before you use the homogeneous differential equation technique, well, you have to check first that the function is homogeneous. Sounds good? All right. Well, let's talk about the idea first. Well, the idea is, here is the idea. Here is the idea of how to solve homogeneous differential equation. So you have two theorems here. So theorem number one is, if you know that the function f is homogeneous of degree m, and g is the function of homogeneous of degree n, f over g gonna be homogeneous of degree m minus n. And if you know that the function f is homogeneous of degree 0, then f is a function of y over x. Well, basically, this is the idea. All right, I'm gonna just sketch the proof for you. So suppose that you have fxy dx, mxy dx plus nxy dy equal to 0 here. Well, you can simplify it to dy by dx equal to negative mxy over nxy. Well, if you simplify it, you just move everything, move dy dx to the left-hand side and move everything else to the right-hand side. So you can see that you're going to get dy by dx equal to negative m over n. And, you know, because you know that m is a function of the homogeneous degree m. This is homogeneous degree m. Your n here going to be homogeneous degree n, right? Well, you know that the ratio here going to be the ratio of homogeneous function. And because, well, suppose that you know that m and n has the same degree. Let's suppose that I know that both of them, they are both degree k, well, the same degree. Then you know immediately that negative m over n going to be homogeneous as well of degree 0. The negative m over n going to be the function that homogeneous as well of degree m minus n. This is the degree k minus k. So this is degree 0. So actually, you're going to know immediately that the function negative m over n, this is going to be the homogeneous function of degree 0. And because you know that this is a function that is homogeneous of degree 0, well, you know, other thing, you know that this is going to be a function of y over x. Once you know that this is a function of y over x, you can do a substitution. Then we can do a substitution. So if we let v equal to y over x, well, if you let v equal to y over x, because this is a function of y over x, then the differential equation will reduce to separable equation. This is the idea. So because, well, I will explain again one more time. So when you have the equation at first, well, when you simplify it to that form, you know that the form on the right hand side, negative m over n, gonna be homogeneous of degree 0. And then by the theorem, you know that if the function homogeneous at degree 0 of degree 0, you know that that function is a function of y over x. Then now you can make a substitution v equal to y over x, and then everything gonna turn to separable equation. All right, so let me summarize one more time. Well, this is the idea, but when you do the question, this is what you should do. So steps to solve homogeneous differential equation. First, simplify until you get mxy dx plus nxy dy. All right, this is the first step. You simplify to this form first. And then number 2, you show that m and n are homogeneous of the same degree. So you have to show that, hey, this given differential equation, this is both function m and n, they are homogeneous of the same degree. And then number 3, you do a substitution, you let v equal to y over x, which means y equal to vx, right? V equal to y over x means y equal to vx. Once you let v equal to y over x, then, well, if you differentiate dy by dx, right? You're gonna get v dx by dx plus x dv by dx. Well, this is because you use the product rule. Well, one more time here. This is the same thing with you differentiate v with let's differentiate y with respect to x, but y is vx, right? Y is vx. So you differentiate vx with respect to x. So you get the product rule. You get you know, v dx plus x dv. And then after that, this is just v plus x dv by dx. If you multiply everything by dx, at the end, you're gonna get dy equal to v dx plus x dv. All right, that is the thing that you can use when you solve the differential equation. And then number 4, if you replace dy equal to v dx plus x dv into the differential equation, then the original equation will turn to a separable equation. In terms of x and v. All right, this is the theory. This is all the theory part for homogeneous differential equation. Well, I know that some of you can say, Ajahn, this is way too hard. You talk something that is so abstract. Well, we're gonna see examples now. Well, after you see example, I hope you feel better. Well, we're gonna see example in a minute. Well, but this is the idea. So keep in mind that when you see differential equation, first of all, you check if it is a separable equation first. If it is not separable equation, well, maybe you simplify it to this form, m dx plus n dy equal to 0. And then you check if it is a homogeneous equation first. Well, if this is homogeneous differential equation, you let v equal to y equal to vx. You let y equal to vx, and then you're gonna get dy equal to v dx plus x dv. And then once you replace everything back into the original equation, it's gonna come back to separable equation. All right. So let's look at example 4. All right. I want you to find the general solution of this differential equation. dy by dx equal to y times x minus y over x squared. All right. First of all, you can see that this is not separable equation, because on the right hand side you have x minus y. So when you have x minus y on the right hand side, hey, you can see you cannot, you know, separate x and y into the product, because you can have x minus y anyway. So this is not separable equation. So the easiest technique is out. You cannot use it. So, well, after that, I feel like, hey, I want to simplify this thing, so I can multiply x squared on both sides. I'm gonna get that one, okay? I multiply x squared on both sides, and then I multiply the x on both sides, just simplify it. And then after that, I simplify to y times x minus y dx minus x squared dy equal to 0. So I simplify it to this form, right? And then after that, I let this thing to be my m. I let this thing to be my n. You know, because I want to check if this is the homogeneous equation or not. So let's look at that. mtx ty here. This is going to be ty times tx minus ty. Because, you know, this is my function m that I highlight in light blue here. So I'm going to just compute mtx ty. And then that will give me t y times tx minus y. And this is t squared y x minus y, and that is t squared mxy. So you know that this is homogeneous of degree 2. All right, you got that. And then let's look at n tx ty here. This is negative. Well, the n here gonna be negative x squared here. Just everything part. I mean, everything including negative side. That is my n. So I'm gonna get negative tx squared, and then I get negative t squared x squared. Okay, good. That is t squared negative x squared, and that is t squared nxy. So sounds good. This is also homogeneous of degree 2. All right. So you got it. You know that m and n, they are both homogeneous of degree 2. All right. So actually, we know immediately that this is homogeneous differential equation. Okay, you can say this differential equation is homogeneous. Okay, and then, well, to solve differential equation here, we're gonna let y equal to vx. Well, the technique is just let y equal to vx, then, well, dy equal to v dx plus x dv. Well, this comes from the thing that you have on the previous slide here. You let y equal to vx, then dy equal to v dx plus x dv. Okay, and then I'm gonna replace everything back into the original equation. Okay, so I have, well, let's look at the equation I have here. That I have a circle here. Well, I'm gonna replace y by vx, and I'm gonna replace dy by v dx plus x dv. So, well, let's look at what I highlight in light blue here. So I'm gonna just replace y by vx, and then I replace y by v dx plus x dv. Well, what I just did is I start from the equation that I circle here, and then I replace y by vx. I replace y by vx. You can see that every position that I have y, every location, I replace it by vx, and v dx plus x dv come from dy. And then trust me, after you plug in like that, this is separable equation. It's guaranteed that this is separable equation. And then after that, well, you just need to simplify it. So I have vx squared dx, okay? And then minus v squared x squared dx. Well, I just, expand it. And I have negative x squared v dx. And then I have a negative x cubed dv equal to 0. You can see that, hey, something cancel. This term and this term, they are the same, so they cancel out. So you're gonna have negative v squared x squared dx equal to negative e minus x cubed bv equal to 0. And then after that, you just need to make it to a function of v on one side, a function of x on another side, right? So here you're gonna have, well, continue here. So I have v squared x squared dx equal to negative x cubed dv. And then I move everything in terms of x to the left hand side. So I'm gonna have x squared dx over x cubed. And then that I have negative 1 over v squared dv. Okay, that means I have 1 over x dx equal to negative 1 over v squared dv. And then I integrate on both sides. So on the left hand side, I have log absolute x plus c1. And then on the right hand side, I have integrate negative 1 over v squared. So I get 1 over v. And then after that, well, my general solution is, you can group the constant. So I'm going to just group C2 and C1 together. So at the end, I have 1 over V equal to log absolute X plus C. Sounds good. This is I just group C1 and C2 together into one side and call it another constant C. And then now, at the end, this is your general solution, but this is the general solution in terms of V and X. you can just do, oh, okay, I have another slide here. Gonna copy that. I ran out of space. So here you're gonna have 1 over, well, your v that you substitute, this is v equal to x, y over x. So this is y over x. Well, this is your general solution. This is the general solution. This is your answer. Or you can simplify if you want, but yeah, this is the general solution you want. All right. Any questions so far? Well, you can see that this technique is not hard, but it's just long. Well, you can see that the journey that we just did, we start from the given differential equation, and then after that, you simplify it to the form here. And then you check that this is homogeneous. And then after that, you do a substitution. And then everything gonna turn to separable equation. And then you integrate on both sides to get the answer. We'll start this question because this is going to be on the final exam. I expect you to solve the question like this in 15 minutes. You know, on the exam, you're going to get the equation that you have here. And then I will ask you to solve this differential equation by using the homogeneous technique. And you have to complete it. Well, you know, I will give it the time about 15 to 20 minutes per one question. And then you have to solve this thing, you know, in 15 to 20 minutes for homogeneous equation. Sounds good? Well, let's do another practice. Well, let's see if you can solve this equation in 15 to 20 minutes for homogeneous equation. All right, so let's do another example, example 5. Okay, sounds good. And then we're gonna have a break, I think. Well, after this question, we're gonna have a break. All right, so let's look at another homogeneous differential equation. So I want you to find the general solution of this differential equation. Okay, first of all, is this separable? So answer yourself, is this separable equation? Well, you can see that this is dy by dx. Well, y prime is dy by dx, right? And then multiply x here equal to y log y over x here. You can see that if you move x to the right hand side, you have that. This is not a separable equation because, well, you have y over x here. You know, inside the log function, you cannot separate it. So this is not separable equation. It is not easy that you can move x to one side, move y to one side, and then done. No, this is not that easy. So what you can do now is just you can simplify it and do the homogeneous equation. So you're gonna simplify it. So you're gonna get, well, first of all, you get x dx, x dy by dx minus y log y over x equal to 0, right? Well, I simplify a little bit. So I replace y prime by dy by dx, and then I move y times log y minus x to the left hand side. Okay, that is what I just did. Nothing fancy. And then after that, I multiply the equation to with dx, so get x dy minus y log y over x dx equal to 0. Well, from the previous step to this step, I multiply dx. And then, you know, this is your, okay. Well, if you want to simplify a little bit more, so you're going to get negative y log y over x dx. Well, this is my m. And then plus x dy. This is my n. Okay. The thing that I highlight in green, this is called the function m. The thing that I highlight in light blue, this is the function n. Well, before you use this technique, mtx ty. Well, let's check first if this homogeneous. Well, negative ty log ty over tx. Then okay, this is t time negative y log y over x. Okay, good. This is just t m x y. Okay, you know, this is homogeneous sticky one. Good, homogeneous sticky one. And then ntx ty. All right, this is easy, just tx. Okay, good. This is just t times nxy. All right, this is also homogeneous of degree 1. All right, and then after that, once you know that, hey, this is homogeneous degree 1, we already got it, then you just let y equal to vx. Good. Then you have dy equal to v dx plus x dv. Okay, and then after that, well, the theory say that once you do a substitution here, if you plug in this thing back to the original equation, it's guaranteed that it's gonna give you back separable equation. So what I'm gonna do is I'm gonna start by this equation, the form that I circle here. Well, you can start whatever you want. If you want to start from the beginning, whatever you want, but just pick the one that you feel like when you replace it, you're gonna get, you know, the nice form. So I just pick this one because it looks clean to me. And then I'm gonna just replace it now. So, well, from that equation that I circle here, so I'm gonna just get x. Well, I'm gonna replace dy by v dx plus x dv. I'm gonna replace y by vx. I'm gonna replace y by vx. This equation that I get here, well, one more time, I didn't do anything other than I plug in y equal to vx and dy equal to v dx plus x dv. And after you simplify, this equation gonna come back to separable equation. Well, it look messy now. It look terrible now. But once you simplify, it's gonna be amazing. It's gonna be just separable equation. All right, so you're gonna have vx dv plus x squared dv. Well, you hope for sure some term gonna cancel out, minus vx log v dx. No cancellation, but let's see, there must be something good that you can, you know, you get separable equation. Okay, I'm gonna move to the next slide. Just copy this one. All right, and then after that, you can see, okay, I'm gonna say this is vx minus vx log v dx. So I group this term that I highlight in light blue together because they do have the same term, the x. So I group them, and then after that I say this is, oops, sorry, plus x squared dv equal to 0. All right, this is separable. So let's do one more thing. So I'm gonna pull out my x over there, so I get v minus v log v times x dx. Okay, looks a little bit better. And then, well, on the left hand side, I have that. On the right hand side, I'm gonna move x squared dv to that one. So you have negative side over there. Negative x squared dv on the right hand side. On the left hand side, I have v minus log v x dx. So now I'm gonna move everything that is in term of x to the left hand side. So I have x dx, I keep it here, and then I have x squared here because I just divided x squared by to the equation. And then on the right hand side, I have negative dv here, and then I over v minus v log v. Can you follow that? This is just the algebra thing, you know. This is algebra. Well, you just, if you are expert in, you know, simplify equations, So you're going to see that it's not that hard. You're just trying to simplify. Well, what I did is I was trying to move everything in terms of x to left hand side, move everything in terms of v to right hand side. And then you simplify a little bit, so you get 1 over x dx here, and then you're gonna get negative dv over v times 1 minus log v here. Well, you can see on the left hand side you have just a function in terms of x. On the right hand side, just a function in terms of y, in terms of v. So you integrate. Okay, you integrate on both sides. So integrate on the left hand side, super easy, right? Because you get log absolute x plus c. Well, on the right hand side, how do you integrate that one? Okay, let's look at that. Well, this is just a note because some of you already forgot how to integrate. So integrate 1 over v 1 minus log v dv. How to integrate it? So for sure, you're gonna pick your u. So you're gonna let u to be 1 minus log v. And then du gonna be differentiate u with respect to v, right? So you're gonna get du over dv, this is 0, and then minus 1 over v dv, right? Just substitution. And then after that, here you're gonna get dv equal to negative v du. Okay, and then after that you have integral of 1 over 1 minus log v dv here. This is going to be integrate 1 over v here gonna be v, and then 1 minus log v, this is u, and then dv gonna be minus v du. And then here you cancel out negative v one time. So here you're gonna get negative 1 over square root u du, which is negative log absolute u plus c. Well, and then you just get the answer here, which is actually one more line here, which is actually a negative log 1 minus log v here plus c. Sounds good. Well, which means, okay, if you have that integration, so you can just get it back to the original equation, and this is going to be log absolute 1 minus log v plus c2. You integrate that, just use the note that you just integrated, and then after that you group constant together, so your answer gonna be log absolute 1 minus log v here equal to log absolute x plus some constant c. This is a general solution in terms of v and x. The last step, just replace v by y over x, because your substitution is y equal to vx. So you're gonna get log 1 minus log y over x equal to log absolute x plus c. This is the general solution for the given differential equation. All right, you can see this is not that terrible, huh? It's just long, but this is not hard. I told you it's just long because once you simplify, you get back to separable equation, you have to integrate. And some of you are weak in integration. You just need to make sure that you can do a substitution, because some of you have a hard time to integrate just this term. But if you can integrate faster than me, you don't have to just show the whole thing in the box over there. Well, because some of you can do integration a lot easier, because well, let me show you a little bit, because I mean, some of you say that, hey, Ajahn, what if I want to integrate dv over v times 1 minus log v, and then some of you are going to say I can do 1 over v 1 minus log v, and then you do d 1 minus log v here, and you get 1 over v here, and then you cancel out here, and then you get, oh, this is 1 over u du, so I get log 1 minus log v plus c. Well, you can do that if you want. Well, this is from calculus 1. You know, if you feel like you are expert in integration, you can just do in one line here. But you know, I know that about 70% of you already forgot Cal 1. So you, well, if you feel like you want to go slow, so you can just do step by step here. Just pick u first, and then do a substitution, and then you get this, and then when you get this, you just come back here. Take your time. Well, because I will give you a lot, you know, about 15 to 20 minutes to complete one question. So this is doable in 15 to 20 minutes. All right. Any questions so far? To sum up one more time, homogeneous differential equation. This is not a terrible topic. It's just way tedious for you. So again, to solve homogeneous differential equation, you simplify first to get this equation, and then show that the function is homogeneous first, and then do a substitution here, and then when you do a substitution here, let y equal to vx, and then dy equal to vx plus x dv, and then you replace it back to the original equation to get the separable equation, and then you solve separable equation. Okay, sounds good. All right, we're gonna have a break first. We're gonna come back at 10:55, and then when we come back, we're gonna learn another one, exact differential equation. Okay, and that would be the plan for today. So when we come back at 10:55, we're gonna come back to exact differential equation, and I will give you a you know, something about some announcement about final exam too. All right, so take a break now, 9 minutes. So we come back at 10:55. So we're gonna learn this thing first, and then at the end, we're gonna wrap up by looking at the topic cover for the final exam. Well, we should stay today 45 minutes more, I think. All right, sounds good, everyone. All right, any more questions? Well, we already passed the most boring and tedious part for the class, which is homogeneous differential equation. So let's look at another type of differential equation. This one called exact differential equation. This is the idea of exact differential equation is pretty simple. So the idea is, if you simplify it to this form, m dx plus n dy equal to 0. Well, sometimes you can see that the thing that you have on the left-hand side match with the form dfxy that you learn from total differential. If you see some pattern like that, you're gonna call this differential equation exact differential equation. Well, it is easier to give you an idea by looking at the example. Okay, I'm gonna look at the example first, and then I'm gonna just go back to the theory, and then we're gonna do more example here. All right, so first of all, we're gonna let's say that if I have differential equation here, 2xy dx plus x dy equal to 0. I want to solve this equation. But once you have this thing, observe that, well, if you have fxy to be x squared y, if you have fxy equal to x squared y here, so by using the total differential that you learned from chapter 4, if you compute dfxy, if you remember, dfxy is going to be fx dx plus fy dy. This is a thing that we learned from the previous chapter when we do the approximation. Do you remember when we learn approximation? I said that, hey, the fxy is this fx dx plus fy dy. So this is the same thing. So if you have fxy equal to x squared y here, so dfxy gonna be that, and you know this is gonna be just fx dx gonna be just differentiate f with respect to x, so you get 2xy. Differentiate f with respect to y, so you get x squared. And what you observe is, hey, Ajahn, this thing, this is the right hand side of differential equation. And this is just the right hand side of the differential equation. I mean, the right hand side here, this, oh, sorry, this is the left hand side of this differential equation. Well, that means this to solve this differential equation, the differential equation is, it is actually on d, well, on the dfxy equal to 0. Because, you know, the thing that I highlight in light blue here, dfxy, this is equal to that. And this thing equal to 0 as well by the differential equation over there. So that means actually dfxy equal to 0. And that means the answer is fxy equal to constant, because, you know, differentiate f, you get 0. So that function is constant. And that means the general solution is x squared y equal to constant. This is a general solution. The answer here. Well, that is the idea of exact differential equation. So let's look at the theory now. So the theory said that when you have the differential equation mxy dx plus nxy dy equal to 0, this differential is called exact if you differentiate m with respect to y and you differentiate n with respect to x, and then they are equal to each other. Okay, this is a theorem to check if the differential equation is exact or not. Sounds good. Once you check that the differential equation is exact, you can get the general solution. Once you check that the differential equation is exact, then the general solution of the differential equation is fxy equal to c. So you know immediately that if the differential equation is exact, then the solution going to be fxy equal to c. You need to find that function f. To find the function f, it's going to be the function that you, this function f going to be the function that you differentiate with respect to x, and then you get m. And if you differentiate with respect to y, you get n. This function f satisfies the two conditions here. F differentiate to x, you get m, and f differentiate with respect to y, you get n. The reason is because, well, you can observe that the fxy going to be f subscript x dx plus f subscript y dy, right? This is by total differential that you learned before. And then here you have the fxy equal to m dx plus n dy equal to 0 as well. So these two things must be equal to each other. So that means, well, your function f that you want is going to be the function that you differentiate with respect to x, you get m. If you differentiate with respect to y, you get n. And if they are equal to each other, I'm sorry, if you have these two equations, you can solve for f. Well, we're going to look at example together, but that is the idea. Well, I'm trying to go fast on the theory, because because some of you are not interested in that thing at all, because you just, and it's understandable because in calculus you just learn how to solve the problem first. So the proof and the theory, you can look at it after if you want, but we're gonna learn how to solve exact differential equation first. So let's suppose that you have this differential equation: x squared plus y squared dx plus 2xy plus cosine y dy. You want to solve this differential equation. What would you do? What would you do? So first of all, you can see that, hey, this is not a separable equation, because you have, or at least you have x squared plus y squared here. You cannot separate x and y into a product for sure. So this is not separable equation. Okay, then if it is not a separable equation, can we let mxy equal to x squared plus y squared? This is my m. And I will let my nxy to be 2xy plus cosine y. Another shot that you can guess, maybe this is going to be a homogeneous equation. However, well, your function m here, this is homogeneous of degree true. But your function n, this is not a homogeneous equation, because you have cosine y here, and just cosine y here, this is not a homogeneous differential equation. So you cannot just use the homogeneous equation technique. Well, if it is not separable, if it is not homogeneous, maybe it's going to be the exact differential equation. The way we're going to check the exact differential equation is, let's differentiate m with respect to y and differentiate n with respect to x. If they are equal to each other, this is exact. Okay, we're going to do it. So we're going to differentiate m with respect to x. What would you get? 2x. Differentiate n. Okay. Oh, sorry. That is m differentiate with respect to y. One more time. M differentiate with respect to y. You get 2y. And n differentiate with respect to x. So you differentiate with respect to x here. So you get 2y plus 0. Perfect, right? Your m subscript y and your n subscript x, they are equal to each other. My equal to nx mean this differential equation is exact. Okay, good. So once you know that this differential is exact, this differential equation has a general solution of the form fxy equal to c. So you know immediately that if this differential equation is exact, the solution will be in the form that function f equal to c, where your function f you can find by, if you differentiate x, if you differentiate that function with respect to x, you get m. And if you differentiate that function with respect to y, you get n. Well, this come from the thing that I highlight here in light blue. So this is the first step for exact differential equation. And then now, well, your task is that you just do whatever you want, but anything at the end, you just need to get function f. You need to find the function f that you differentiate with respect to x, you get m. And you differentiate with respect to y, you get n. So what I'm gonna do is, well, because I know that the function that I want, I differentiate with respect to x, I get m. So that means the function I want, if I start from m here, if I integrate back, with respect to x, so I should get f, right? Because the function that I have, if I differentiate with respect to x, I get m. Well, why don't we just reverse it? So if I have m, just integrate it back, so I should get f. So I am going to try to integrate x squared plus y squared here, dx, because I hope that if I get that function, I can get function f back from there. I integrate x squared, get x cubed over 3. I integrate y squared dx, so I get xy squared, and then I integrate. Well, actually you need constant, but the constant here going to be the constant in term of y, hy. Well, why do you need to have hy here, not just constant? Because you integrate with respect to x. When you integrate with respect to x, anything in term of y going to be constant. Think of it. Well, when you integrate with respect to x, anything that depends on y, you treat it as a constant. So when you add constant here, it must be a function of y. Because whatever you have, you're gonna treat it as a constant because this is a function of y. This is just the notation for a function of y. All right, that is my function f. So my function f, okay, good. I have x cubed over 3 plus xy squared plus just some function of y. I don't know yet what is that. Well, from that thing, I also know that if you differentiate with respect to y, you get n. So I'm gonna just use the function that I have here. Differentiate with respect to y, and then I should get the function n. So we're gonna copy it there. This is my function f, because we know that if I differentiate that function f with respect to y, I get n right here. Well, that means you have differentiate f with respect to y, get 0, I get differentiate x cube over 3, you get 0, differentiate xy square, you get 2xy. And then you differentiate hy, you get h prime y. So this is differentiate with respect to y, you get that. And this thing must equal to n. Your n is 2xy plus cosine y. Okay, good. Then that means h prime y equal to cosine y. And that means just hy here gonna be integrate cosine y dy. Well, this is just integrate in one dimension now. So you're gonna get sine y plus c. Okay, good. I have hy. So at the end, conclusion, my fxy gonna be x cubed over 3 plus xy squared plus hy, which is sine y plus c. Well, this is my function f, and the general solution is fxy whole c. If you want to say that function is going to be x cubed over 3 plus xy squared plus sine y plus c equal to c. But this is different c, but you can group it into one c, so this is just c. You can call that in c1, okay? And then, well, you group c1 to c, you get c. Okay, does it make sense? Well, this is how we solve the. This is how we solve the differential equation, the exact differential equation. So by looking at this example, you can see that the idea is when you start the problem, you should check first if the differential equation is exact. Once you check that the differential equation is exact, you know that the general solution will be in this form. And then you just need to solve for that f. Well, the function f you are looking for is the one that you differentiate with respect to x, you get m. You differentiate with respect to y, you get n. So what I just did is I have m here, I integrate with respect to x back, so I get f. And then this is my function f. Well, I still need to verify the function here, hy, because, you know, it's the constant in term, the constant here can depend on y. And that means, yes, I can just use f subscript y equal to n, another condition, to solve for that function h, and at the end I get fxy, and my general solution is going to be that. Okay, one more example. Okay, let's look at example 8. Okay, let's find the specific solution of this one. Well, basically we're going to find general solution first, and then we're going to use the initial condition here to plug in to find constant after. All right, wow, the equation looks pretty complicated and terrible, but we need to simplify first. Okay, first of all, we are going to do that. We're gonna copy everything here, 2xy over x squared plus 1 minus 2x minus 2 minus log x squared plus 1, and then y prime is dy by dx. Well, I didn't do anything other than just, you know, switch the y prime to dy by dx. I put parentheses here to just make the world easier. This is my parentheses. Okay. I multiply dx. So I get 2xy over x squared plus 1 minus 2x dx, and then minus 2 minus log x squared plus 1 dy. Okay. And then after that, you have this thing. This is my m. This thing, this is my n. Okay. You know, this is okay. Your n is going to be everything included negative side here as well. Okay, this is my n. Well, you need to make sure that the differential equation is exact. Well, for sure, this question, you're not going to do separable equation. You are not going to do homogeneous equation. You're going to do the exact differential equation. We're going to just differentiate m with respect to y. We're going to differentiate n with respect to x. And if they are equal to each other, yes, this is exact. And then you can just solve for it. Okay, we're going to do that. My m is that function, right? We're going to differentiate with respect to y. So if I will think together, if I differentiate this term with respect to y, so I get 2x over x squared plus 1, right? Differentiate with respect to y, you treat everything in terms of x as a constant. You differentiate negative 2x with respect to y, you get 0. Okay, so I get 2x over x squared plus 1. And then I have n here. I differentiate with respect to x. So differentiate 2, you get 0. Differentiate log. Well, first of all, negative sign here, gonna group it up to positive. And then differentiate log x squared plus 1. So you get 1 over that. And then inner function, so 2x. Wow, they are the same. So, okay, my equal to nx. So this differential equation is exact. This is the first step that you should do. The next step is, once you know that the differential equation is exact, well, you can claim that the general solution is of the form fxy equal to c. Up to this point, you know, if it is on the exam, up to this point, you get 50% already. Well, another 50% is you need to find the function c. How do you find the function c? Well, we know that the functions, I'm sorry, to find the function f. Well, I think I I spoke too fast. So I want to find the function f. So f x y here. The thing that you know is, you know that the function f here, you differentiate with respect to x, you get m. And if you differentiate with respect to y, you get n. Okay. Well, you're going to use these two conditions to find f. Now it's like a puzzle. You just need to do whatever you can just to find f. Well, but as I told you, the basic technique is, because you know that the function that you are looking for, you differentiate, you get m. Why don't you just integrate that function back with respect to x? So you're going to get f, right? But when you integrate here, you have to be very, very careful, because the constant here is going to be a function of y, right? Because you integrate now, it just, your function m here is in 2 dimensions. So when you add your constant at the end on this step, it's going to be a function of y. Okay, so I'm going to integrate that. Okay. It looks terrible, but hopefully it's easy to integrate. All right, how could you integrate that? Not hard, not hard. So I'm gonna just copy to the next page. All right, this is my function f. So let's integrate that. Okay, how to integrate that thing, indefinite integral. So first of all, I'm gonna just pull out my y. So I have integrate x, 2y. Okay, I have x over x squared plus 1 inside over there. Then dx, that's the first thing, and then minus integrate 2x dx here. We'll just simplify a little bit. And then after that, I 2y here. So I need to get x over x squared plus 1 here. Dx squared plus 1 2x. And then minus 2 integrate x dx. Well, I don't know if you can follow me, but the integrate that I want to integrate, that I highlight in light blue here, well, you can solve it by using substitution u equal to x squared plus 1. If you pick u equal to x squared plus 1, so you can integrate easily. And then after that, you're gonna have 2y here. So at the end here, you're gonna get, okay, 2 and 2 here cancel. So at the end, you're gonna get y times x cancel. So you're gonna have integrate 1 over x squared plus 1 dx squared plus 1, which is log x squared plus 1. So for those of you who are super weak in integration from Cal 1, the step that I highlight in light blue here, this is done by Cal 1. Just integrate, doing a u substitution. Just pick u to be x squared plus 1, and that is how I integrate it. And then after that, you integrate x dx, so you get x squared over 2. And then you do not forget, when you add some constant here, the constant going to be a function of y. The constant is going to be a function of y. You have to be careful on that thing. All right, so that means your function f here going to be one more time, y log x squared plus 1 minus x squared plus a function of y. This is your candidate for the function f, right? However, we also know that if you differentiate f with respect to y, you get n. So you're going to differentiate this function with respect to y. So you differentiate that thing I circle here with respect to y. So you get log x squared plus 1 plus 0 and then plus h prime y. This is the thing that you differentiate f with respect to y. This is equal to the function n that you have in the question, which is here, that I highlight in green. This is the n, which is actually negative 2 minus log x plus 1. Okay. Negative 2 minus log x squared plus 1. Okay. Okay, now it's just time to solve for h. On the right hand side, you get log x squared plus 1 minus 2. Okay, that means h prime y equal to negative 2. And that means hy equal to integrate negative 2 dy. Right? And that means your hy going to be negative 2y plus c. Let's say c1, constant c1. So when you have h already, so come back to sum up. This is your f. Your f is going to be y log x squared plus 1 minus x squared minus 2y plus some constant c1. And then the general solution. General solution is fxy, which is this function, is equal to some constant c. Okay, done. This is how to solve the exact differential equation. Sounds good? I have a question in the chat. Some of you asked me privately, I don't understand why f subscript x equal to m and why f subscript y equal to n. So the reason why we set up f subscript x equal to m and f subscript y equal to n. This is because when we prove it in the theory part, you know, the differential equation is the form mxy dx and nxy dy equal to 0. So we get this equation, m dx plus n dy. And by the definition of exact differential equation, it means there exists a function f such that dfxy equal to that. But dfxy by its definition, it's going to be fxy plus fy dy, because its definition by total differential, this is the definition. Okay, that means you can just look at these two equations and then you set it up to be, you know, this term must be equal to each other. That's why you can set up f subscript x equal to m and f subscript y equal to n. Well, basically the answer to the question that Sarataya asked me, well, that is because from the proof, in order to get the general solution of this form, you need the condition that fx equal to m and f subscript y equal to n, because you equate these two equations. It is an algorithm to solve this differential equation. Does it make sense? Well, hopefully it does. Okay. Well, let's see, indicating factor. Do we have time for that? Well, I think we're gonna stop. We're gonna stop here and we're gonna pick up the remaining topic after. So I want to spend the last 30 minutes, you know, because the topic today is so heavy in terms of they have so many equations or something. So we're gonna just stop the lecture, the new content here, but we're gonna just show you the final exam. Okay, just give me 10 minutes more and then we can go. All right, any question in general? So I'm gonna share something from my laptop. Or any question in the meantime when I fix my laptop now? Okay, I'm ready. Okay, everyone see that? So the final exam, okay, here. So the final exam gonna be on May 12th, which is 2 weeks from now. So May 12th from 1 p.m. to 4 p.m. So save your date. This is going to be our final exam. So basically, this is the content that will be covered on the exam. Limit and continuity that you learn, partial derivative that you learn, higher order derivative, the chain rule, how to approximate the function using differential, how to identify local max and min by using the second derivative test, double integral over general region, double integral over polar coordinates, separable equation, homogeneous equation, exact differential equation, integrating factors, and linear differential equation. Okay, so the format for the final exam gonna be like this, because last time I did a survey from all of you and you said that you want to show your work question. So I'm gonna split the exam into two parts. So part number one, it's gonna be the live part. So what I mean by live part is on the final exam day, we're gonna ask you to get into the Zoom at noon. And then we're gonna do the multiple choice equation in the first hour. In the first hour, I think I will create about 15 easy multiple choice questions. Not 20, it's too much, I think. So I'm gonna create about, well, not sure about the number now, maybe 15 to 18 easy multiple choice questions. What I mean by easy multiple choice questions mean when you read the question, you can answer immediately. No need to do the hard computation. Maybe I'm gonna ask just the, something that you can answer in 1 or 2 minutes, just the easy question, just to check that you know the concept. That is the part that is the multiple choice question. So you expect to answer multiple choice question, like each question in 1 or 2 minutes. Just quick, just when you read the question, you can answer it immediately. For example, I could ask something like, hey, I give you a function f. What is derivative of this function f with respect to x? So let's say I have fxy equal to x squared plus 5x plus 6 plus cosine y. What is the partial derivative of this function with respect to y? You can just, okay, differentiate one time, and then you find the multiple choice you want. Simple, in 1 or 2 minutes, you can solve this question. So that is going to be the live part. So on Wednesday, May 12th, I will ask you to join Zoom together. Everyone to have to join Zoom on the first hour and open the Blackboard, and you're gonna do the multiple choice question in the first hour. And then after that, in the last 2 hours, which is 2 p.m. to 4 p.m., it's gonna be the take home part. So you can quit the Zoom at 2 p.m. And then after that, you download the question from the Blackboard. Well, the same thing as the quiz. And then you're gonna have the take home part. Well, you will have 2 hours to complete 8 questions. Question 1, this higher order derivative and the chain rule. Question 2, approximation using total differential. Question 3, identify local max and mean and zero point by using the second derivative test. Question 4, 5, and 6, double integral. Question 7, homogeneous differential equation. Question 8, exact differential equation. So for question 7, I'm gonna tell you that, hey, this equation is homogeneous, solve it. And question 8, I'm gonna tell you, hey, this equation is exact differential equation, solve it. So you expect to solve each question in 15 minutes. That's why I give you 2 hours to complete it. And then after that, 4 p.m. to 4:15, upload the exam back, upload the paper to Blackboard. And that is your final exam, 40%. Sounds good? So show your work part 8 question here. So you can practice on those topics if you want. The exam is open book. So if the take home part is open book. Well, if you feel like, hey, you practice a lot, you have everything in your hand, you just want to copy the thing that you already practiced, fine. So the take home part, this is the open book. To be fair, you just, you can open your notes, and well, if you are a good student, you study a lot, you don't want to miss some steps, so fine. So 2 p.m. to 4 p.m., this is the take home part. Or you can open book, you can use calculator, you can do anything you want, just do it by yourself. Well, for sure, the exam gonna be, so the exam 8 question here for sure. We're gonna have 50 form of exam. Well, you're gonna get different question compared to your friend for sure. Different question from different people, yes. For different people, yes, for sure. Well, I can create 100 form of exams for you, but just to make sure that you focus on yourself, do it by yourself, and then question 1 to question 8, just do it, and then you upload it back by 4:15. Okay. Well, any questions on that format about the exam? Well, I'm gonna just post this thing again and put it in the live group, and post in the Blackboard again about the the formal instruction. But this is just the draft now. Anything else? Any question in the chat? Well, I have a question from Coach Shimon. She said, will you give the, well, in each question, 8 question here, do you have the sub question in there? So the answer is no. It's gonna be like one big question and then you solve it. It's similar to the example in class. So if you attend class regularly and then you understand my examples, you do practice problem, well, these 8 questions shouldn't be a problem for you, for sure. Everything gonna be already covered in this class, and it looks similar to my examples. Sounds good? Well, and there's no, well, could be a sub question. Well, I can ask you a lot of things, but it is not just like 4A, 4B, 4C, 4D, just way too long. Well, you expect that one question I'm going to give you just 15 minutes to solve it. So it must be not that hard. It's just the easy one or the medium one. Sounds good? Or anything else? Any question? So for the multiple choice part, you do not need to be worried. It's just super easy, trust me. It's just the one that you can answer in 1 or 2 minutes. When you read the question, you're supposed to answer quick. Just want to check. Nothing on theory, yes. This is the easy computation, like easy computation. Good. Sounds good. Okay. Next week, well, before you go, next week on Monday, it is a national holiday. Well, when I asked the BBTech office, they said that we can have a class. Well, do you want to have a class on the national holiday, or do you want me to record the clip and you watch after? So answer me in the chat. Can you attend the class on next Monday? Class, can you attend the class next Monday, which is a holiday, national holiday? Yes, right? Okay. Okay, well, so we're gonna have a class next Monday as usual. So we're gonna complete the last topic, which is integrating factor and linear differential equation. So next Monday we're gonna complete the handout, and on Wednesday and Friday we're gonna do a review. Does it make sense? So for those of you who wanna take a day off on the national holiday, I think it is a make up for a Labor Day, because a Labor Day in Thailand is May 1st, which is on Saturday, and they have a make up of the Labor Day national holiday on Monday. But we're gonna have a class anyway on Monday at 11. But if you feel like you want to take a break on the make up national holiday, so you can watch the clip after, then fine for you. But for those of you who can attend, just please come, because this is going to be the next Monday will be the last lecture. We're gonna look at integrating factor and linear differential equation. These 2 topics will not be covered on the exam. Okay, let's see. These 2 topics will not be covered. Well, I will send this file out later. This two topic will not be covered. Well, I will teach you anyway because this is in the course syllabus, but because we're gonna learn next Monday, and it is not fair for you to test on the topic that you don't have time to digest or you don't have time to study. So we're gonna just learn it, but it will not be covered on the exam. The exam gonna be cut off up to exact differential equation up to today. Okay, I think this is fair for you. All right. Any questions? Well, when we look at the chat again. Well, yeah. Well, let me answer each question of the exam. So Shri asked, the exam is on the 12th, right? Yes. Save your date. Book your date. It's Wednesday afternoon. Wednesday, May 12th afternoon. Yes. Natakia say, okay, that's in Thai. Nida say, Nida told me we have to find approximation as well. Yes. Well, I told you on the question number 2 here, approximation, you need to find approximation. Remember the question I asked you to find, like square root, 3.99 square plus 4.02 square, something similar to that question. You need to use differential, total differential to approximate a function. If you study on that question, you shouldn't have a problem with question 2 here. But if you use calculator immediately without using calculus, of course you get 0, because I will ask you to use total differential to approximate. I didn't ask you to use calculator to approximate. So if you use calculator, you're gonna get 0 for sure, because I want to see steps that you use differential to approximate the function. Anything else? Well, again, next week, Monday, we're gonna complete the handout, and then Wednesday and Friday, we're gonna do a review. So if you feel like you wanna study with me, don't wanna study alone, you can attend the review class on Wednesday and Friday. Well, but for those of you who wanna study alone individually, yeah, I respect you, because you have different way to study. Some of you have more concentration when you study alone. Some of you are better when you learn in groups. Well, but that's the plan for next week. Anything else? All right, sounds good. All right, thank you everyone for attending today. Then, if you don't have any question,
Thank you.
Thank you. Well, I will keep you posted